What if one injection into your liver could protect your brain from Alzheimer's? I know that sounds a little silly, but a study just published in Neuron this year, the 6th of May, 2026, and it's making some serious researchers sit up. This finding is actually important for those with APOE4 mutations, and I wanted to talk a little more about it. Here's the background you need. There is a version of the APOE gene called APOE4, the one associated with significantly higher Alzheimer's risk. But researchers have also been quietly studying the opposite end of the spectrum, protective variants. The most striking one is called APOE3 Christchurch. It came to wider attention when scientists found a woman who carried 2 copies of a presenilin 1 mutation, a gene that normally causes Alzheimer's to begin around age 44. But because she also carried 2 copies of APOE3 Christchurch, she was good until her 70s. I will cover this in my video called Baisa Gene Mutation, because this is very interesting and it was discovered in Colombia, of all places. If that interests you, do subscribe to my Midlife Brain Project YouTube channel, where I explain in layman terms a summary of my research about dementia prevention. Suffice to say here, this APOE3 single genetic variant could provide decades worth of protection. The obvious question is, can we give people that protection if they weren't born with it? To answer this question, we have to go to China. This team in Chongqing, China, packaged the APOE3 Christchurch gene into a viral vector and injected it into mice with Alzheimer's-like pathology. They saw reduced amyloid plaque and cognitive improvements. That alone isn't unusual in mouse studies. What's different here is where they delivered it. Not the brain, but the liver. Most gene therapy for Alzheimer's tries to cross the BBB, which is the blood-brain barrier, which is very, very difficult to do safely at scale. This approach instead uses a standard liver-targeted vector, the kind already in clinical use for other conditions. The mechanism is simpler than it sounds. You need to know that the liver clears amyloid beta from the brain. It does so by acting as a peripheral metabolic sink. This idea of a sink, I also talked about it in my previous video about the lithium hypothesis. Anyway, as your circulating blood flows through the liver cells bind and degrade up to 60% of the body's amyloid beta. What this APOE3 Christchurch does in the liver is supercharge a system that your body already has. So the liver already does this, and the APOE3 Christchurch supercharges this mechanism. To conclude, mouse models of Alzheimer's have a painful track record of not translating to humans. But the mechanism is novel, the delivery system is already clinically validated. So in a way, it's worth exploring. And this is also important for those who have increased risk because they are APOE4 carriers. That's all I have for today. Signing off as Dr. Mark Chern from my Midlife Brain Project. Thank you for listening.